we'll discuss about the magnetically coupled circuits. In previous class, we discussed about the magnetic coupling. We studied differential coupling, cumulative coupling in series circuits, series magnetic circuits, and also in parallel magnetic circuits. After that, we studied single phase AC circuits and followed by three phase AC circuits, balanced and unbalanced loads. Right. So now we'll combine these two, so AC circuits along with magnetic circuits. Right. So we are already studied that concept of self-inductance and mutual inductance. So let us assume this is L1 and L2. So this is having the mutual inductance M, right? This is having the mutual inductance M. So how you represent this L equivalent?
Sir, for cumulative coupling, L1 plus L2 plus 2M.
Right. For differential coupling, it will be L1 plus L2 minus
2M.
2M, right? So how exactly it is plus 2M or minus 2M, right? In otherwise, so how exactly the mutual inductance is aiding the total inductance, or it is differentiating the total inductance? So that is denoted by the dot notation, right? We already studied that. So this is the current entering point, right, of this particular coil, and this is the current entering point for the particular coil, right? So in this case, so what it is known as, what it is known as, what kind of coupling it is? Hmm? So here also the current entering and here also the current entering, right? So this is known as what kind of coupling it is?
Cumulative, sir.
Cumulative coupling, right? So in this case it is L1, L2 plus 2M. This is the current entering and this is the current entering for this particular coil. Okay. So we have some intermediate circuit will be there. Right. So here also you have some intermediate circuit will be there. So that will not comes in picture right now. So what is it's known as differential coupling? So it will be L1 plus L2 minus 2M. L1 plus L2 minus 2M. Understood? Okay. So in this particular connection, if this is the current entering and this is the current entering here, so this is known as cumulative coupling and this is known as differential coupling. So this is also true. Something like this. This is dot here and this is dot here. So in this case also it is cumulative coupling. Sorry, differential coupling. So this is differential coupling and this is cumulative coupling. So we already studied these things, right?
Yes, sir.
Okay. No confusion, right? So you may wonder that, so how the current is entering here, how the current is entering here. Okay. So here, so this is under the assumption that, so we have some intermediate circuit is there. Okay. So let us assume that we have two circuits, something like this. So here the dot is placed here and another dot is placed here. So its mutual inductance is J3 ohm and this is minus J4 ohm and this is J6 ohm, that is its self inductance of this coil, and this is J5 ohm and this is 12 ohm and the source voltage is 12 at an angle 0 degrees, and here you have positive, negative. Right. So in this particular circuit, if we assume this is I1 phasor and this is I2 phasor, find I1 and I2. Clear? So this is the problem. It is given. Right? So now the question is, so how to solve these kind of problems? So how to solve these kind of problems? Right? So now, if these two are not coupled, so in this particular case, so how to solve this? So these two are two separate circuits, right? Agree? These two are two separate. If this mutual inductance is not present, so in this case, these two are two separate circuits. You can directly calculate I1 by applying KVL here, and you can calculate I2 by applying KVL here. This is simple, right? But these two are coupled. So meaning is, right? So meaning is, so here, so what is the current flowing in this inductor or in this winding? So what is the current flowing here? So I1 current is flowing here, right? So here I2 current is flowing. Agree?
Yes, sir.
But the thing is that, due to the presence of I2 current, so due to the presence of, let us assume that this is coil 1 and this is coil 2. So due to the presence of current in the second coil, due to the presence of, or due to the current flowing in the second coils, so there will be a mutually induced EMF in the first coil. Agree? So due to the current flowing in the second coil, so there will be a mutually induced EMF in the first coil. So vice versa, there is a current flowing in the first coil. So here, so there will be an induced EMF in the second coil. Agree?
Yes, sir.
So that means, so here you have one induced EMF, here you have one induced EMF. So the induced EMF will vary. So how exactly it will vary? Based on the current, so that is flowing. So based on the current, so that is flowing. We have this, right? So it is induced EMF, so that depends on the current that is flowing into its mutual inductance. So now the question is, so how to decide the polarity of that induced EMF? So now the question is, so how exactly you decide the polarity of the induced EMF, right? So let us consider the first case here. So here this I1 current is flowing here. Okay, I1 current is flowing here. So this is J 5 ohm and the dot is here, and somewhere you have other circuit is there. Okay, and here the current, what is the current here? I2. Agree? So we have, this is the full circuit. Right. So here these dots are placed here. Right. So we have think that, right? So here, so first we'll see the influence of, right, the influence of this I1 current, right? So influence of this I1 current in this I2, or influence of the first circuit current in the second circuit. So here the I1 is entering the dotted terminal. Agree? Agree?
Sir.
So this is how I1 is entering the dotted terminal. If I1 is entering the dotted terminal, right? So in the second circuit, the induced EMF, so where you have dot, so that will be the positive polarity. So here the second circuit you have dot here, right? So this is positive and this is negative. So this is the direction of, or this is the polarity of induced EMF.
Sir, once again, can you please repeat, sir?
Yeah, I will repeat. If this dotted terminal, if the dot is entering, so if the current is entering the dotted terminal, right? In the other circuit, so the dotted terminal, polarity means the dotted terminal, at the dotted terminal you have positive polarity.
Okay, sir.
Right? So that means this is the induced EMF. What is the magnitude of this induced EMF? Anyone?
J6 into I2.
Hmm?
J6 into I2.
J6, J6, why J6? So mutual inductance is J3.
Yeah, 3, sir.
Oh, sorry.
J3 into
J3 into I2, sir.
why I2?
I1,
This
sir.
is due to the current I1, right?
Oh, okay, okay.
Agree? So we have this mutual inductance M here, and this is the current due to I1. Agree? So that's why, so this magnitude is J3 into I1. Clear? Understood?
Yes, sir.
It's very simple, right? So if the current is entering the dotted terminal in the coil 1, right? In coil 2, so where you have dot, so that will be positive. Simple logic. If the dot is here, so that means this is positive and this is negative. That's all. Okay? Right. Similarly, so we have to see the influence of second coil on the first coil, right? So here, okay, I'm deleting this one. I will write again to just avoid the confusion. Okay, we have make sure that this is plus J 3 into I1 is there. Okay, so here, so come to this circuit. So here, the current I2 is entering the dotted terminal or leaving the dotted terminal.
Leaving, sir. Leaving, sir.
Leaving.
So the
Entering,
current
sir.
I2 is leaving the dotted terminal. The current I2 is leaving the dotted terminal. So that means the other dot or the coil 1 dot. So where you have dot, so that is negative. Understood?
So not understood.
What is there to not understood? So here,
Sir, it is
as
entering,
it-
sir.
see here, the current is I2 is leaving the dotted terminal, right? So
Yes,
this is
sir.
dotted terminal or this is undotted terminal, right? Agree?
Yes, sir.
So here the current is entering the undotted terminal, right?
Yes, sir.
Okay. So in previous case, the current is entering the dotted terminal, the other dot is positive. Simple. So now the current is entering the undotted terminal. In that case, the dotted terminal is negative. So that's why to avoid confusion, if the current is leaving the dotted terminal, the other dot is negative. This minus plus. Just simple. Clear?
Yes, sir. Understand,
So
sir.
just note down if you want to refer again. If a current, note down, if a current enters the dotted terminal of one coil, if a current enters the dotted, if a current enters the dotted terminal of one coil, if a current enters the dotted terminal of one coil, the reference polarity of the reference polarity of the mutual voltage, the reference polarity of the mutual voltage, the reference polarity of the mutual voltage in the second coil is positive. The reference polarity of the mutual inductance in the second coil is positive. In the second coil is positive at the dotted terminal of the second coil. 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 Or, so there is another one. If the current leaves the dotted terminal, if the current leaves the dotted terminal, if the current leaves the dotted terminal of one coil, if the current leaves the dotted terminal of one coil, the reference polarity of the mutual inductance, the reference polarity of mutual inductance, the reference polarity of the mutual inductance, the reference polarity of mutual inductance in the second coil, in the second coil, the second coil is negative at the dotted terminal of the second coil, at the dotted terminal of the second coil. at the dotted terminal of second coil. At the dotted terminal of second coil. Understood? So no confusion, right? So no confusion, right? So here, so what is the magnitude of this mutual inductance? What is the magnitude of this mutual inductance in this particular case? So what is its magnitude?
3 I2.
J3
J3
I2.
I2. Right?
Yes, sir.
So this is a voltage, right? So this mutual inductance is voltage, but it is controlled by the current in the other circuit. Agree?
Yes, sir.
So how you will represent this?
Positive side on the dot, sir.
Mhm.
Taking EMF dot as
No,
positive.
that's not the question I'm asking. That is over. So we are the polarities we already assigned. So now the thing is that, so here, so this one is voltage source, right? This is a voltage, right? Agree?
Yes, sir.
But here the current is I1, but this voltage magnitude is controlled by the other circuit current I2, right? Other circuit. So how you will represent that? So this can be represented by a dependent source. Agree? Okay.
The current
So how you
dependent
will
voltage.
represent this voltage? So it will be something like this. So you have a capacitor. So this is the induced EMF. So this is the induced EMF, right? So what is this polarity here? Tell me. What is the polarity here? This top polarity?
Downwards.
Huh?
Down arrow will be.
Polarity, that is a voltage source, right? Why
Oh,
arrow will
minus
come?
plus, sir. Minus and plus.
Why minus? So this is minus here, right? So
Yes,
just
sir.
bring it down. So minus plus. So what is its magnitude?
J3 I2.
J3 I2.
J3 I2. Agree?
Yes, sir.
So rest of the
Yes,
things
sir.
are same. One at 12 at an angle 0 minus J4, and this is J5 ohm. Similarly, you have other circuit. So this is also represented by a dependent source. So this is J6 ohm, and this is 12 ohm. So what is the magnitude and what is the polarity? What is the top? This polarity here.
Plus, sir. Plus.
Plus,
So
sir.
this is plus minus, right? Just bring it down. So here plus minus, right? Just bring it down. So which is in series, right? So this is J3. What is its magnitude? J3 into I1. Agree? Agree? So
Yes,
why
sir.
we are represented with the dependent sources? So here the induced EMF in the first coil is depends on the second coil. Right? So that's why we are represented with a dependent voltage source. Clear? Right? So what is the next step? So this current is I1, right? Agree? And this current is I2. What is the next step?
KVL.
So KVL. So apply KVL here. So this is plus minus, right? Apply KVL. Tell me what is KVL if you apply KVL.
12 plus J3 I2.
12 at an angle 0. What is the other voltage source?
J3
A
I2.
2 voltage source, right?
J3
What is that
I2.
value? Plus or minus?
Plus, sir.
Plus.
Mhm.
Plus.
Plus.
Currently is leaving the positive terminal, right? It's plus only.
Yes, sir.
J3 I2.
I2.
So this is equal to how much? Minus J4 I1. Agree?
Yes.
Plus
J5
J5
I1.
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 This is equation 1. So what is the second equation?
J3 I1.
Hmm?
J3 I1 equal to
J3 I1. Yeah, J3 I1 equal to J6
Mhm.
I2
J6
plus
I2
12
plus
I2.
12 I2.
12 I2.
plus 12 I2.
12 I2.
Just solve it for I1 and I2. Okay? You know how to solve this, right? So this is how to solve a simple coupled circuit. This is how to solve a simple coupled circuit. So you have any doubts? Any doubts you have?
No, sir.
Okay. So then we will solve another problem. So between these two, the mutual inductance is J4 ohm. Okay, so this is mutual inductance J4 ohm. That's all. So this is 230 at an angle 0. So here one dot here, here another dot here. So in this particular problem, find out the current through 4 ohm resistor. So I 4 ohm. You need to calculate.
Sir, where is 4 ohm resistor in this circuit?
Sir, the 4 ohm is not.
4 ohm not there, no? Sorry, 2 ohm. 2 ohm. This is first resistor, 2 ohm.
One is mutual inductor. J4 or J2, sir?
Which one?
Which one is the reactance of mutual inductance?
J4, no? This is J2 self-inductance. This is self-inductance. This is the middle one. That is J4. Okay. So how to solve? So this particular kind of problems is, again, the approach is same only. So assume this is current I1 here, right? So this is current I2, right? So what is the next step? What is the next step? So we need to
Assigning polarities.
EMF.
identify the mutual voltage
Polarities.
polarities, right? The simple way we already have studied the basic things, right? So what is that thing? So from this, so wherever you have mutual inductance, so that means, so that is denoted with a dependent source, right? Agree? So this is the first circuit, and this is for the second circuit. You agree for this?
Yes, sir.
Okay?
Sir.
Agreed for this, right? Yes, someone is saying something. So this is, there is no change here. So 2 ohm. So this is minus J6, sorry. Minus J6 ohm. So this is 230 at an angle 0. And this is J6 ohm. And this is J2 ohm. And this is 6 ohm. Right? What is the next step? What is the next step?
Polarity of EMF.
Polarity of
Mutual
voltage.
inductance, right?
Yeah.
So here come to this case, we will identify the polarity of this one. Change the color. So I want to identify the polarity of this particular source, right? So this is due to the current in the other coil. So what is the other coil? Is J6, right? Okay. So here, if you notice that, so this I2 current, right? This is I2 current is leaving the dotted terminal, right? Agree?
Yes, sir. Yes, sir.
I2 current
Yes,
is
sir.
leaving the dotted terminal, right? So if it is leaving the dotted terminal means the
Dot will
first
be
coil
negative.
dot will represent the negative. Agree?
Negative.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Sir,
Right.
I2 is supposed to enter, right? Because I think the dot, sir, I2 is going in a clockwise direction. So basically it's supposed to enter, right?
Where
I2.
it is
I2, like,
supposed to
sir,
leave the dotted terminal. This is dot here, right? It is leaving the dotted. So see, simple, you are missing the logic. So this is entering the dot, the current leaving the dot. Okay.
yes, yes. Yes.
So this is entering. So this is the current is entering first, right? And the current is leaving the dot. This is leaving. This is simple. Understood? So now tell me what is current? It's leaving the dot, right? If the current is leaving the dot, the other dot, the circuit, other circuit dotted terminal will be negative. So that means this is negative and this is positive. Agree? So this is negative and this is positive. Agree?
Yes, sir.
So just bring it down properly with the same. It must be in series with that, right? Minus plus, right? Must be in series with that. Okay, because it's induced EMF. So that's an additional component. What is its magnitude?
J4.
J4 I2.
J4
J4 I2.
I2.
Good. It's J4 I2. So now come to this circuit.
Dot will be
First
positive.
circuit. So here, in the first circuit, right? So what is the current entering in the first circuit or leaving in the first circuit?
Inductor current leaving
Entering, sir.
at
The
the
depending
dots.
on, so how you are, what is the exact current that is flowing inside? This is what is the current flowing is here?
I1 minus I2.
I1 minus
I1
I2.
minus I2.
I2, right? So this I1 minus I2 is entering the dotted terminal, right? Agree?
Yes, sir.
Yes, sir.
Okay. So that means here plus here, minus here. So here minus here, plus here, right? Just copy paste here. So what is its polarity? What is its magnitude?
J4 I1 minus I2.
J4 I1 minus I2.
J4 I1 minus I2. So remember, this is how you are considered, right? For example, so don't be confused. So for example, I consider here. So in this case, what is the current, that net current that flowing through this branch?
I2 minus
minus
I1.
I1.
I2 minus I1.
I1.
So current is entering or leaving the dotted terminal?
Leaving.
Leaving.
Current
Leaving.
leaving the dotted terminal. That means this will be minus and this will be positive, right? So what is its magnitude? J4
J4
into
I2 minus
I2 minus I1.
I2 minus I1. Both are same, right? Agree?
Yes, sir.
Okay. So no confusion, right? One second. Right. So this next step is, so we have to choose this I1 current and this is I2 current, right? So next apply KVL here and apply KVL here and solve for I1 and I2. So here the question is the current through this particular branch, right? That means you need to calculate only I1. So let us have some problem like this. So this is J2 ohm, right? And this is 4 plus J6 ohm, 4 plus J6 ohm, and this is J5 ohm, and this is J20 ohm. Mutual inductance here K is given, that coefficient of coupling is given, so that is K equal to 0.5. So find out Vx. Find out Vx. Oh, sorry, I forgot to give the dots. So you have one dot here and another dot here. So how to calculate the
Sir, the frequency of the source is not given, sir.
why frequency is not required, no?
Sir, because mutual inductance is coefficient of coupling into square root of L1, L2, na sir. And they gave the impedance
They gave
value of the
XL.
inductor. Yes, sir, they gave the impedance value of the inductor, not the inductance value.
What is the formula for M?
K root L1 L2.
K root
K into root
L1
L1
L2,
L2.
right? Okay. Simple thing, right? So if you
into root
multiply
L1
K
with
into no sir.
hmm,
K into root
K
L1 L2.
K into root L1 L2.
sorry, K into root L1 L2, right? So now tell me, is that in frequency is required or not?
Not required, sir.
Not required, right? If this L1 L2 are in Excel form, so this MA is also in Excel form. Agree?
Okay, sir.
Yes, sir. So, what's the polarity of AC source?
This is plus, top plus. If nothing is given, that means the top plus is. So what is the value of M?
J5.
J5.
M is J5, right?
J5.
Okay. So we can have, oh, sorry. So we can, right. So we can replace this circuit with something like this. A dependent source. Sorry.
Both are same polarities, sir. Yeah.
Mhm.
Both will have same polarities.
So let us assume that this I1 here and this current is I2. Okay. This current is I2, right? Okay, no? So now tell me, so what is the polarity of this one? So what is the polarity here? What is the polarity here?
Minus plus.
Sir,
Minus
minus plus.
Minus plus,
Top.
right?
Top minus.
So what is the polarity here?
Plus minus.
Plus minus.
Minus, sir.
Plus minus. The
Plus
current
minus.
is entering, right? So plus minus.
Top plus.
Simple,
minus.
right? So this magnitude is J5, I2, right?
Yes, sir.
Agree?
Yes, sir.
And this polarity is
J5
J5. How much it is?
I1.
I1.
I1, right? Okay, no? Clear? So now, so what is this value? So just rest of the things are J4 ohm, and this is 440 at an angle 0, this is plus minus, and this is J5 ohm, and this is J20 ohm, right? So now how to calculate? What is the next step?
KVL.
So KVL, right? So apply KVL. So now tell me what is the value of I2? What is the value of I2?
Sir,
Sir, right, sir. Circuit is not complete. How can I
sir,
do
loop is open, na?
That's why.
Sir.
What is the value of I2?
0?
Yeah, correct only. So IT is 0, right? Somehow I need the open circuit. This is open circuit, right? Somehow I need the open circuit voltage across this terminals, right? So this
Yes, sir.
I2 is 0 only. Okay? I2 is 0 only. Clear? I2 is 0 only, right? So now tell me what is I1. So how you will, so this entire thing is 0 only because there is no current flowing in this circuit or in this one. So that means this value will be 0 only. This is clear?
Yes, sir. Yes, sir.
So why I2 is 0? So one side you have open circuited, right?
Open
So that
circuit.
means, so this is 0. What is the current that's flowing through this one is 0 only. So now tell me, right, what is this one? So 440 at an angle 0,
Equal to
440 at an angle 0 equal to,
uh,
yeah,
Sir, 4 plus J7 into I1.
yes, sir.
4 plus J7. So we
J7
need to add all that, right? So minus J4 minus J5. What is that? Plus J1, right? Agree?
Yes, sir.
Yes, sir.
Plus 4.
J7 plus 4.
4 plus J7
J7
into I1.
I1
Agree? So what is the value of I1? 440
upon
at
4
an
plus
angle
J7.
0 by 4 plus J7.
Tan angle tan inverse.
So what is this value?
Sir, 8.06 at an angle 60.25.
8.06. No.
Sir, means I1 value, denominator value.
Okay, no, okay. So you are saying that 440 at an angle 0 is how much?
Sir,
8.06 at an angle
60.25.
Okay, 60.25. So tell me what is I1 value? I'm arranging this. What is I1?
So 55, 54
55.
point,
Oh,
sorry,
yeah.
54.6.
6 at an angle minus 60.25
25.
amperes. Okay, clear?
Yes, sir.
Right. So this is not over. So we need to find the open circuit voltage across the open circuit voltage across. So these terminals, right? So if you notice that, so this is voltage, open circuit voltage. So that means this entire thing, right? Agree?
Yes, sir.
Okay. In other words, so it will be this thing. So this voltage, this voltage, this voltage, this voltage. This entire voltage is the open circuit voltage, right? Agree? Agree for that?
Yes, sir. Yes.
So what is the current that flowing through this one?
0.
0.
Zero, sir.
So what is the current flowing through this one?
0.
0.
So this one is
Minus J5 I1.
J5 I1, right? So that means why minus this plus minus only, right? So J5 I1, right? Agree?
Yes, sir.
Plus 4
Yes, sir.
plus J6 into. So what is the current that is flowing through that
I1,
branch?
I1. I1, sir.
I1.
I1.
I1, right? So this is
Yes,
I1.
sir.
So this is equal to Vx. So
Vx.
Vx is, so if you add this one 4 plus, how much
J11,
it is?
I1, sir.
J11, 11 or 12?
J11.
J11.
11.
J11 into I1.
I1.
Okay? Just multiply with that, so that you'll get the answer. Is clear? So we'll try to solve another one. This is one. So this is 120 at an angle 0, right? So this is J40 ohm, and this is J60 ohm, 60 ohm, and this is minus J50 ohm, and this is J80 ohm, and this one is 100 ohm, right? So there will be, so 3 inductance. So there will be mutual inductance from here to here. So there will be some mutual inductance between these two windings. So between these two, so this mutual inductance is J10 ohm. Okay, so that mutual inductance is J10 ohm. So from here to here, say a mutual inductance, right? So its value is J60 ohm. No, not 60, J30 ohm. Its value is J30 ohm. And you have dot here. and from here to here, so you have mutual inductance, and that value is J20 ohm. Understood? So we have three circuits are there. So let us assume that is 1, 2, 3. So between 1, 2, so you have mutual inductance. Between 2 and 3, you have mutual inductance. And between 3 and 1, so you have mutual inductance. So try to solve this.
Sir, what should we find out, sir?
What should we find out? Okay. Anything you just find
Current,
the
sir.
current. So this current, say, find Ix. So current through 100 ohm resistance. Just try to find 100 ohm resistance. It looks like complex, but is it actually easy one, right? Agree? Look like complex, so but it is exactly easy one, right? Okay. So now let us assume that, so this is coil 1 and this is 2 and this is 3. Okay. So how many voltage or how many mutually induced voltages so that will act on coil 1?
2.
2, right? Similarly for coil 2,
2.
2 for coil 3,
2.
2, sir.
right? So each one is having so two dependent sources in series with that. Agree?
Yes, sir.
Sir,
So no confusion, right? So just try to redraw that. So you have one dependent source. So you have another dependent source. Okay. So you have one dependent source and you have another dependent source.
sir,
Yes.
can't we add both of them and make it as single, sir?
How can you add? The currents are different, no?
Okay, sir.
Okay, let's see. Its possibility is there. You'll try to add. Okay. We are just learning the procedure, right? This is your circuit. Agree? So this is minus J50 ohm. This is 120 at an angle 0. So this is J40 ohm, J80 ohm, and this is J60 ohm. Okay. Right. So first thing first. So first we have first winding, first coil is there, right? So we had two mutually induced EMF, right? Okay. So we have dots here. So this is first dot. I can better change the color. So you have one dot here, another dot in the bottom. So here another dot here. Okay. So assume that, so this current is I1 and this current is I2 and this entire current is I3. Right. So now tell me if this is due to coil 2 and 3. Okay. So this is due to coil 3 and 1, if going in order wise, and this is going to coil 1 and 2.
2.
If we assume this is coil 1, J40 is coil 1, J80 is coil 2, and J60 is coil 3. So that's how we assume it, right? Okay. So now tell me what is the magnitude or what is the polarity of this one?
Current is Ix minus
Sir,
I1.
plus
Minus.
minus I2
Minus
minus
plus.
I1 into J10.
Right. So here the current is entering. So what kind of current is entering here? What is entering here?
Sir. I1, sir.
Why
I2
I1?
minus I1.
I2 minus I1, right?
I2 minus I1.
I2 minus I1 is entering the dotted terminal, right? Agree?
Yes, sir.
Can I take I1 minus I2, sir?
Then it will be leaving.
Yeah, it is leaving, right? We already discussed that there is nothing wrong if you take I1 or I2, right? So here, so what is the current is entering here? So this is the current, right? So what is exactly it is entering? I2
I1
minus I1, right? Agree?
Sir, I1
If
minus
I2
I2.
minus I1 is entering, so here this dotted terminal, so this is the dotted terminal, right? So here plus minus, right? Agree?
Yes, sir.
Agree for that? So here plus here, minus here. So what is its magnitude?
I2 minus I1 into J10.
What is its mutual inductance? Is J10, right? J10 into I2 minus, is it visible here for you? I2 minus
sir.
I1. Agree? So now come to coil 3. So what is the current that is entering the coil 3?
I2.
Sir, I3 minus I2.
I3 minus I2.
Yeah, you can assume anything, right? If you have positive polarities, right? So for example, if this is the current entering the dotted terminals, right? So what is the current it is entering here? I3 minus I2, right? Agree?
Yes, sir.
So this dotted terminal here, another, this is also positive and this is also positive. So you have plus minus. So what is its magnitude here?
J10 into
J10.
I3
Why
minus
J10?
I2.
Why
J20.
J10?
J60.
Why J60?
Sorry,
What is
sir.
the mutual
J20.
inductance between 1 and 3?
J20, sir.
J20, good. So this is J20 into
I3 minus
I3
I2.
minus I2.
I2.
Understood? No confusion, right? Okay. So now come to second coil. Right, come to second coil. This is, we assumed as due to first coil, right? What is the polarity and magnitude here? What is the current that is flowing?
Half plus I1 minus I3.
What is the current? So that is flowing.
I1 minus I3.
So this is I1 minus I3. Okay, if you assume that the current is entering. Okay, so this is the other dot, right? So that means this is plus minus. Agree?
Yes, sir.
Yes,
Agree?
sir.
So what is its magnitude? What is its magnitude? Between 2 and 1 we are doing, right? So what is its magnitude?
J10 into
J10 into
I1
I1 minus I2.
I1 minus
I3.
I3. J10 into I1 minus I3. Similarly here,
Minus plus J30 into I3 minus I2.
minus plus,
J30.
y minus plus. Okay, so this is
I-
3, 2, 3 and, so this is 1 and, so 2 and 3, right?
Yes, sir.
Okay.
It is entering I3 minus.
So what is the current here? Okay, if we
I3
assume that, so this current is entering here. So that means what is the polarity here? Minus plus, right? Agree?
Yes, sir.
Minus plus, what is its value?
J30.
J30
J30 into
I3 minus
I3
I2.
minus I2.
I3.
3 minus
I3 minus I2. Okay. So you can complete this one, right? Similarly, you can complete this one. So if you quickly complete this one, so what you will get here?
Plus minus.
What you will get? First one.
Sir, J20 into I1 minus
I3.
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 J20 into I1 minus
I1
I3.
minus I3.
I3.
So this plus minus, right?
Yes, sir.
Yes, sir.
Yeah, correct. So second one,
Sir, J30
Answer
into
J30,
I2 minus I1
J30 into I2 minus I1
plus minus left side plus.
plus minus, right?
Yes, sir.
Okay, I2 minus I1. Okay, no? So what is the next step? So just solve for I1, I2 and I3. That's all. Okay. Agree? Understood?
Yes, sir.
Just simple. Okay. Look like complex, so but it is actually a simple one. Okay. So you have any questions in today's class?
No, sir.
Okay, right.
No, sir.